My name is Austin Arnsberg, and I lead Okta Ventures. I'm very excited to introduce Immuta to Octane 21. Immuta provides a cloud-native data governance platform for organizations to automate data access control, security, and privacy compliance. Okta Ventures invested in Immuta to fund continued product innovation and joint go-to-market initiatives focused on the expanding market for cloud-based analytics. This integration will help organizations like the Center for New Data simplify identity management and provide secure data access within multi-cloud and hybrid data analytics environments. We've seen our customers at Okta face many of the pain points that Immuta is addressing as the continued explosion in enterprise data makes management and access control come to the forefront. Please enjoy this presentation, and we are excited to work together with Immuta to support our mutual customers.
So start just to set the stage by defining a couple of terms. Let's start with DevOps. The DevOps is a combination of software development and IT operations. It's really a combination of things like cultural philosophies, practices, and tools that enable companies or organizations to deliver software products, like things like applications or services, and to do that faster than using traditional approaches to software development and infrastructure management processes. And when we talk about DataOps, kind of like DevOps is emerging as the cloud unlocks and modernizes data. And so the way we look at it is that DevOps is really optimized for maybe software products, and DataOps is emerging as a kind of a parallel function or discipline for building data products for the purposes of analytics or other downstream uses. And DataOps may or may not be widely used in your organization, but the respective bottlenecks we'll cover in the webinar for most cloud data teams are definitely top of mind. And so I'm going to turn it to Paige now to more define DataOps from an industry perspective.
Sure. So I think one of the things you always struggle with, and me as an industry analyst, it's practically my job, is defining some of these emerging concepts. And there's a certain level of perceived ridicule that can come along with putting ops as a suffix onto any term of the day. But I think with data ops, one of the really important things to remember is that this is trying to essentially elevate the use of data within the organization and really embed it into the data culture of an organization. So functionally speaking, when we look at data ops as a definition, we sort of use the description of using more automated and agile approaches to data management to drive these data-driven outcomes within an organization. And that sort of contrasts with some of the traditional approaches to insight initiatives or analytics within an organization where you could have very ad hoc efforts of, say, an analytics group working towards a certain defined objective, or a data science team just working sort of in their own room towards their own other defined objectives. Data ops is really an organization-wide term that's looking to leverage data as that lifeblood and that key foundation for business outcomes throughout the enterprise or throughout the business. So really trying to enable your everyday workers, whoever they may be and whatever their roles may be, and ensuring that they have the right access to the data that they need so that they can drive insight that's valuable within their role. And I think that's sort of that broader definition of what data ops is trying to achieve. So less ad hoc, more systematic. So if we move on to the next slide, of course, there are some barriers. So when we're looking at organizations that are wrapped up in these self-service initiatives, obviously self-service is a huge part of what organizations are trying to achieve when they're enabling their workers to deliver business value in their roles with data. So as a bit of an introduction on the 451 research and S&P Global Market Intelligence side, where I come from, we run a series of surveys on a quarterly, semi-annual basis where we look into, the challenges, the practices, what's being done with data within organizations. So some of the data that I'll be walking through today is sourced directly from those survey cycles. And what we have here is asking organizations what their biggest barriers to self-service analytics, visualization, and data preparation are. So looking at those core self-service functions. And you can really break down barriers into sort of people-oriented challenges, process-oriented challenges, and then finally, technology-oriented challenges. So some of the top challenges that are recurring are cultural or organizational in nature, like training of your self-service users or the persistent lack of budget. But once you start to dig into the actual technical challenges, we see things like quality of that data emerging as a top concern, with 27% or so of organizations reporting that challenge. And then furthermore, as the self-service ecosystem grows and more people want to get access and use of that data, security and access control become a major concern. How do you strike that balance between ensuring that workers can get the data they need that's appropriate to them, but also ensuring that there's not an overreach in terms of that use and accessing data that may be unintentional in the sense that it could be more sensitive than it needs to be. So again, striking that balance between facilitating ease of use and ease of access with ensuring that the proper controls are consistently applied. So I think we can move on from there.
All right, so in the next section, we want to dig into the state of data operations today, and we'll look at some more of this data. And as Paige mentioned, there's some 451 research, and we have some research from Immuta and my team. So this is sourced from the Data Engineering and Operations survey in 2020, the back half of last year. And approximately 140 respondents from an Immuta source database. It's not necessarily our customers, just our database of folks we interact with and subscribe to different content. And two trends came out of this. And the first one is that we're looking at the respondents responding 75% will be entirely or primarily cloud-based in the next 24 months. And trend two is that over half, 52%, plan to adopt two or more platforms in that same time frame. When we say platforms, a cloud data platform is like a single platform or service used for analytics or processing data. Might be like a data warehouse, a data science platform, or ad hoc query engine. And that for you is that it's pretty obvious, but you'll be managing or expect to manage more of these types of services in your platforms and cloud strategies. And we believe that this timeline's been accelerated in part due to the COVID pandemic that hit earlier this year. And so we'll look at some additional data from Paige to dig into some of these numbers in her separate survey work.
Yeah, so on this slide here, this is again pulling from the 451 Research S&P Global survey data that we conduct on a regular basis. And if you think of the last year or so and just the extraordinary global situation that really evolved out of the coronavirus pandemic, one of the things we looked at was the changing behaviors and trends of organizations as they tried to adapt their business models with these challenges in terms of digital delivery of the customer experience and connecting with clients in new ways and sort of meeting the new demands as business had to pivot. And what we've seen in general is that the pandemic overall over the last year was really driving higher cloud usage on average. So even if you look at the data very much in aggregate, very much broad brush strokes, we see that more than 50% of organizations are reporting that they're using a higher proportion of cloud-based technologies in their IT environment than they used to. And only 3%, a very minuscule amount, are using a lower proportion. The remainder essentially are still on their original trajectories, so using technology in essentially the same way they had been. But one of the interesting things that we look at, if you go back to say roughly mid-summer in 2020 and looking at some of the behaviors and how these organizations were reporting their IT practices, one of the interesting things that emerged was it was organizations that were sort of in the middle of the cloud maturity curve that really started to jump forward. So again, on this slide, we have a sort of average aggregated changes in cloud use, but digging into that data, we'll see that the organizations that were sort of in the middle of their cloud journey actually jumped forward the furthest. So you have cloud laggards to some extent that are tend to be slow to adopt, and you have some of the forward-leaning organizations that are adopting prior to COVID. But we saw a very significant shift in that middle of the curve, which makes up most organizations in any given market, was actually jumping forward the furthest, and this being sort of a pivotal event that was driving forward that increased cloud adoption, with, of course, the hyperscaler public cloud providers getting much of that increased usage. So moving on. And again, breaking down the impact on select IT initiatives from coronavirus pandemic specifically, this is an interesting set of data. This was taken from June of 2020, so really at the middle of that shift in business where it became clear that, at least in the US, that coronavirus was going to be both likely persistent and also a major impact on business. And one of the most interesting things to note here is that in many cases, the most common answer for impact on select IT initiatives, whether that be information security or whether it be analytics, is that most things were continuing on their original timeline. So most organizations in these core IT functions were deciding to stay the course and stay on plan. It's much more rare for organizations to say they were delaying or canceling their IT-led initiatives. In many cases, such as information security tools and practices, as we see as the second reply on this chart, there were certain factors with the pandemic that were actually really vaulting forward those practices and those initiatives. So 29% actually accelerating their actions in that regard, because you have this expanded work from home. You have to manage a diverse array of cloud data sources. You have to secure everything properly in this new working environment. And even going down to data analytics projects, half of organizations are saying they're continuing on their regular timeline, but there's still opportunity there in that these insight initiatives, data analytics projects, are actually being pushed forward as sort of an impetus to get that additional insight in what may be an adverse business or economic environment. So generally speaking, in 451 Research's survey insight, we've seen that organizations over the last year have sort of had a wedge driven between them, in that it's a have and have not scenario, where organizations that were already starting to lean forward with their analytics insight initiatives are pulling further ahead, and those that were hesitant to invest in that regard are falling further behind because of the difficult business climate. So again, the takeaway being here that most of these projects are continuing as planned, and in some cases, they're actually being driven forward and accelerated. So moving on.
All right, so going back to some of the Immuta survey research on these trends, to dig into that 75% statistic, and to build on what Paige talked about, some of the things are on track and acceleration to cloud in other cases. The 75% represents the future state of when organizations will be entirely or primarily cloud-based. But also to dig into, we also asked what the current state is, and almost half of the respondents were primarily on-premises or all on-premises. And so that represents a stark contrast from half to be mostly on-premises to 3/4 moving to the cloud. And 1 to 2 year period. And so cloud migration can be complex and multi-year as well. So this timeline does support some of that data, and some of it was ongoing or accelerated due to factors like COVID or business needs. And to dig into the second trend around the diverse cloud platforms that we observed, again, this is looking at the trend around cloud data ecosystems, which are one or more cloud platforms or data platforms. And they're becoming common as cloud adoption matures. So this includes several types, and you can see some of the responses on the right. But there's different types of cloud native services for querying and processing data that organizations are adopting. So things like cloud data warehouses. You can see Synapse and Redshift and Snowflake are popular choices. And then other types like data science platforms like Databricks is number 2 in this response. And then some ad hoc query engines like Athena or maybe Starburst. And there's other responses below. We'll just highlight the top 5. But the net takeaway, the diversity is showing like a dimension of maturity where some of those analytics projects are using best of breed platforms and services in the cloud as they start to expand that footprint. And so when we look at some of this data and around the movement to cloud, and let's start to look at some of the emerging challenges. And so from the research from Immuta, we surveyed those primary data architects and engineers were the bulk of the respondents. And the challenges are really shifting towards the management of, I would say, sensitive data when you look at the top 3, like classifying and cataloging data, monitoring and auditing, and masking or anonymizing. And some of the least challenging areas for managing data are around extracting and loading, which a lot of that becomes streamlined with cloud storage or data lakes. Some of the work moves upstream. And then to dig into some of these values a little bit more, there's a couple dimensions here, and they reflect some things around cloud data maturity. So from the perspective of 1, the cloud vendor, they're adopting, and 2, from an organization perspective. But from 1, for the cloud vendors, when we started to dig into responses and talk to actual respondents to the survey, there's a pattern that the challenges are in early stages of cloud data maturity, where maybe they moved a couple of use cases, but the data management tools are still being adapted, the ones they're currently using for cloud use, or maybe the cloud tools from the public clouds are still in nascent stages for their use case. That's one level. And second, from an organization's perspective, these challenges tend to increase with maturity from an adoption perspective. So moving maybe like 1 or 2 use cases from, let's say, an on-premise database to the cloud for like, let's say, 50 users is a quick way to get wet in the cloud. And the data management challenging in those cases may be somewhat challenging or less challenging. But when you get more mature data ecosystems that support those new use cases for like big data, data science, or data sharing, you have more classes of users who have different roles. The challenges or the responses that's where we saw some of the most challenging responses in these different buckets. And as the challenges shift towards managing sensitive data, and we're seeing more diverse cloud platforms, you can look and see what happens with some of the around data access governance. And this is increasingly heterogeneous, where each cloud service, whether it's like something like Google BigQuery or maybe Spark or Athena, they have different access and privacy controls, and it creates challenges for data engineering and operations to manage, and it multiplies some of the risk, cost, and maintenance for each platform or service you add. And so this is really the result of the rapid acceleration and maturity and sophistication of the best of breed platforms and services that we saw in some of the Immuta survey data. And when we look at some of the more granular dimensions on how is adding each cloud platform multiplying risk, cost, and maintenance. So this is the technology, that gives a mix of people, process, and technology in some cases, but the dimensions are on data platforms, like how many do you have, data use rules, Maybe it's a contract or agreement for third-party data use or exchange. There's different geographies you have to factor in when you're looking at your cloud ecosystem. Numbers of tables, which can be thousands, and data lakes. There's also regulatory concerns, data sovereignty, and things like that. And then lines of business. How do you isolate tenants for different requirements across your internal customers, or maybe external sharing? And so this really requires data teams. This can add up to like 50,000 plus policies. And just this example, you're even over 100 policies is difficult to manage. But it really requires data teams to evolve. And Ryan later from the Center of New Data is going to touch on how they leverage automation to manage data access in these types of environments. And I guess we'll go back to Paige to talk about some of the implications for data-driven organizations.
Sure. So as one of the things we look at 451 Research, especially over the last year, has been how do you build this supporting fabric and infrastructure for a data-driven culture within your organization. So as I mentioned earlier in the presentation, some of these initial efforts around data science, around insight initiatives, analytics, reporting were very ad hoc in nature. They're becoming more interdepartmental and more complex in terms of workflow and the number of roles that are involved, the number of people and dependencies that exist in these processes. So think of perhaps, a high-level decision maker within the organization getting the data they need. That represents a very complex and nuanced workflow to get to that point where they can make their decision. And data culture is all about building that. So when we ask organizations today what they're doing to build their data culture and invest in data culture, it's perhaps surprising that the top response is not employee training or data literacy. That's a skill that can be built, but it looks like the top responses at 44% of organizations, they report that they're investing in new data management products and services. It's actually a product and technology forward approach. And if you think about that, and if you drill down into it a little bit more, it makes sense because data culture itself is fundamentally based on data. And if you don't have that baseline control of your data, if you can't control who can access it under what conditions and control how that data is served to individuals and subgroups within the organization and ensure data quality, data integrity, things like that, any efforts around literacy or skills are likely to be less successful, because at the end of the day, it comes down to the data itself. So when we look at investment in new data management products and services, and as the runner-up, investment in new analytics products and services, you'll see that breaking that down, much of the focus is for departmental and line of business decision makers. And that really aligns with the overarching trend that we're seeing in terms of self-service and making all of those knowledge workers enabled and facilitated in their efforts to access and use data to drive value within the organization. So again, the takeaway being that you can't have data culture without managing your data to begin with. So I think we can move on.
All right. Kayla, you want to introduce the Center for New Data?
Sure. Yeah, thank you both. I mean, I think that's with cloud data analytics being so central to how we work and live these days, it's really important to recognize and definitely get ahead of all those challenges. But now we'd like to introduce Ryan Naughton, the co-executive director at the Center for New Data, who will walk us through how their company securely operationalized sensitive data to help stop the spread of COVID-19. Ryan, take it away.
Awesome. Thank you so much. So the Center for New Data, we were born out of the COVID pandemic, and we're a new kind of nonprofit that really is bringing data engineering, proprietary data sets, and sort of all the techniques used by Silicon Valley firms to help in social impact research. And so specifically, we've built a cutting-edge cloud research and data science platform. We've secured partnerships with proprietary data vendors, and those include data vendors with over 2 trillion rows of de-identified smartphone geolocation data, voter registration records for 200 million Americans, and other data sets as well. And then we bring together volunteers of data scientists, data engineers, DevOps engineers from all around the world, and they support academic research teams from Columbia University, University of Chicago, UCLA, on public policy research. And sort of a key philosophy here is demos, not memos. And so as such, we really work with partners, both grassroots organizations, as well as media partners, such as the Center for Public Integrity, Washington Post, Fair Fight as a grassroots organization, all to drive impact on the ground. And really at the center of this is a cloud research platform where we have data governance and a hub and spoke model as how do we sort of change the nature of collaboration by empowering researchers to really turn data into action. Next slide. So we have 2 primary program areas, and one of those, the Observing Democracy program. We've utilized our proprietary data sets in order to understand sort of the nature of democracy in ways they've never been able to understand before. For example, we've measured wait times at polling locations throughout the country. We did this in conjunction with University of Chicago and Carnegie Mellon professors. And with de-identified smartphone data, we sort of transitioned the world from self-reported wait times, which were always sort of inconsistently measured and sporadic and didn't have adequate coverage over the country, to a true measure of wait times across the entire country, across 90,000 polling locations. And the result of that large-scale measurement was it, in coordination with grassroots organizations, we were actually able to reverse poll closures in the Georgia Senate runoff and actually increase voter access and fight voter suppression. So very real, tangible policy impacts from mobilizing sensitive data in these specific manners. Additionally, we've worked with Columbia University on Get Out the Vote efforts and measuring the effects of billboards, and we're working on an inclusive redistricting project with UCLA law researchers to help ensure that people choose their congresspeople as opposed to politicians choosing their voters. On the COVID Alliance side, we've used the same sort of data sets in order to measure social distancing, done analysis of major super spreader events such as the Sturgis motorcycle rally, and we've really helped drive public health guidance from public health departments, as well as getting sort of the message out through major media partners on how Americans are taking the pandemic. Are they taking it seriously? How does that impact the actual spread of the disease? What are travel patterns, et cetera? Next slide. So our cloud research platform is built using the amazing help and support of all of our partners. This includes Immuta, Snowflake, Okta, Saturn Cloud, Astronomer, Aliata Consulting for privacy consulting, and Pachyderm, and more companies in the list, but all these folks have been absolutely amazing and supportive on really how can we take the best in class solutions and bring them to social impact work. Next slide. Here's just kind of a quick view of our architecture. We have several different secure enclave environments. We have an ingestion environment that's separated from the rest of our ETL environments for managing ingestion of this sensitive data, goes into our compartmentalized data lake. And then from there, we spin up data pipelines, whether some are Airflow, some are Pachyderm. Soon we're piloting DBT. And all of those are isolated on a per sort of project basis that enables the researchers and the volunteers to only gain access both from an Immuta perspective to the data sources they should need, but also even from a service accounts and data pipelines perspective, where we have isolated ETL infrastructure for different parts of our research environment. That leads to then cloud Jupyter environments, and those cloud Jupyter environments enable researchers, data scientists, data analysts to do research in sort of an environment they're very familiar with, however, never having data leave our cloud environment. And so it's within our secure VPC. These researchers are spinning up using our Kubernetes cluster cloud Jupyter environments. They can do their analysis and spin those down at will as well. And the final piece is that all leads to a Looker data visualization layer. And sort of at key points throughout this, we use Immuta. And so as an example, our end users and our data scientists, when they're in those cloud Jupyter environments, are generally using Immuta managed Snowflake native views. And sometimes our ETL pipelines use Immuta as well. So we don't want to introduce sort of random noise early in the process with the data pipelines, but for things like masking and redaction. And so, for example, our voter registration data, our ETL pipelines don't need the names or addresses of those voters. They need other metadata about those voters. And so we mask all of those fields, even for the ETL pipeline that's accessing those. Next slide. So why do we need gates, and what is this concept of a gated sandbox? Well, we want to drive knowledge creation and have a hyper collaborative environment, but we have to recognize that sort of empowering use of sensitive data also comes with the risks of that sensitive data being used inappropriately. And so because we have this proprietary data, and also because it's literally trillions of rows of data, we have to manage access both for compute purposes, for tracking of compute, and for ensuring that sort of reuse of data in a form of data primitives is the sort of collaborative approach we want, as opposed to it being a free-for-all open environment. And so within our environment, we ensure that each team has a review of what access they should have, and then sort of pair them up into an environment that creates a Immuta project, creates Snowflake roles as a consequence, and allows us to actually manage which team has access to which data appropriately. Next slide. Sort of our pyramid of new data creation. If you have a 2 trillion row data set, the average academic researcher has no idea how to handle a 2 trillion row data set. And so after ingestion, our sort of initial stage of data engineering is to create what we call data primitives. And these data primitives are things like, dwell clusters, which devices were dwelling at which locations, home attribution, in what area does someone live, demographic enrichment of that device based upon its behavioral attributes. And that sort of data engineering layer creates these reusable primitives that now many different data science purpose-built research projects can build off of, whether those are, the Observing Democracy program areas, our COVID Alliance programs, or we're expanding into poverty, social determinants of health. All of these can sort of share core data primitives and really enable a new form of collaboration that is really about reuse and repurposing of different data primitives. From there, those data pipelines result in data visualization layers, and those get disseminated to grassroots organizations, media partners, et cetera. Next slide. So really, in terms of data governance, where does Immuta fit into our stack? So as I alluded to before, it's primarily used by end researchers in our cloud Jupyter environments, but we also use it even for some ETL pipelines, and we want to manage masking and redaction. Because we are a cloud-first platform, we're primarily Snowflake currently, but we're exploring BigQuery and Databricks. So having a unified governance layer is just very appealing to us. Additionally, we currently have 106 data sources registered in our Immuta system. And so it enables a data catalog for data discovery. So new researchers can look within that environment, and without actually seeing the data, they can see a data inventory of that data, a data dictionary, descriptions of the data, and understand what is available, and then request access through that platform. Then from an access perspective, we're primarily using projects. And what we've really sort of found is a useful concept is going from role-based access controls to attribute-based access controls. We can roll all of this up into the concept of a project. And so one researcher can switch from doing research on project A to project B, and simply by switching their role within Snowflake, Immuta has managed all of the aspects of what they should have access to. And that's not simply a role-based approach. It's because of the attributes that researcher has on them as an individual as well, allowing us, even within a team, different levels of access. One of the key things that's been very useful to us is data masking. And really, it's not just masking sensitive columns, for example, names and addresses, but it's also sort of controlling how we can manage joins. And so a researcher maybe should have access to certain types of data, but that unique ID per device doesn't mean they should be able to join that to other data sets easily. And so being able to manage which data sets can be joined easily with other data sets through appropriate masking policies that really include, should this be salted in a way that is no longer joinable, has been very helpful to manage isolation of teams effectively. And we're at the early stages of exploring the use of k-anonymization and the differential privacy solutions offered by Immuta as well. Next slide. So here's just a quick example. For Thanksgiving, we did research on travel patterns. The CDC had advised Americans to not travel for Thanksgiving. Our data indicated that between 30 and 40 million Americans still traveled a significant distance, traveled to over 100 kilometers from their home, and we were able to measure which areas sort of had the worst social distancing compliance, which areas had the greatest inflows of travelers, greatest outflows of travelers, that were either going to import or export COVID based upon the prevalence of the disease in those areas, and get that out to both media partners and sort of a broader public health initiative to help people be aware of the risks of this. Next slide. And so sort of looking at this as a life cycle, we've built out our research platform. That research platform is now really enabling us a lot of test use cases. And those use cases, one example is the Sturgis motorcycle rally that happened last August. We worked with Washington Post on sort of a seminal piece that demonstrated that the implications of that event were sort of a leading indicator of the massive amounts of COVID that happened throughout the middle of the country, and that COVID cases far and wide across counties all over the US were attributable to that singular super spreading event. And when the Washington Post, for example, reached out to public health departments throughout the country, those public health departments were themselves not aware and not doing a great job of tracking the impacts of Sturgis on their own local community, how many cases they'd imported from this event. And yet our data was able to help both Washington Post and other groups actually find those cases and demonstrate that our sort of tracking infrastructure at a county, state, and national level are just insufficient to actually handle this pandemic. We've sort of now expanded scope from there, and we're really finding how can we scale our impact. And that kind of goes to that premise of data primitives and how we can reuse core data concepts across many research teams. And in so doing, find the appropriate privacy controls and appropriate access controls to empower researchers with access to the data that they need without everyone getting access, for example, to raw geolocation pings data. And so we're working, for example, on a housing insecurity project using the same data primitives we've used before in order to measure housing insecurity as a leading indicator, how much people are sleeping at the same place night after night, and how we can use that to understand, sort of an indicator of housing insecurity much earlier than when people actually show up at a homeless shelter. And that kind of wraps our efforts, and happy to take any questions you guys have.